All right, good evening, everyone. Please confirm that you can see and hear me. Okay, that's great. Um, we'll begin now. If you are not like, I would advise that you look at the bottom left corner of your screen for the text that says live. That text should have a red dot beside it. If that dot is gray or not red, then click on the text. It should bring you to the latest frame of the live stream, because it's very important that you be on the latest frame so we can engage better. And welcome to the live stream. Let's begin. Today we'll be talking about inverters. So today we'll be talking about inverters, and once again, please make sure you're on the most recent live stream by clicking the live button that's at the bottom left of your screen. So let's begin. Um, like I said, today we'll be talking about inverters. And before I begin, I would like to congratulate you on your progress. So far, we have treated basic electronics, mathematics. We have treated what's it called now? Panels. We have treated wires, controllers, batteries. We have treated system design. And you have an assignment. I hope everyone has a team now. That's very, very important. And as you know, the deadline for the assignment is Tuesday. So I strongly recommend you work on it as soon as possible. So let's begin. Inverters are not are the last major thing we'll be treating in our training, and it might be the last live stream we have. And also not be, we might also have to talk about protection systems such as breakers, surge, and so on and so forth. But anyway, inverters are like the one of the most important parts of a solar system. They don't really do anything special. Let me put it that way. It's raining again. Yes. No, no. This rain is going to be a lot of noise. Oh boy. Oh boy. Oh boy. So I'm going to try and try to be audible. If at any point you feel like being audible enough, just let me know. Maybe postpone the live stream or make it a Google Meet, because this rain is not going to work well. The sound is too much. But inverters actually perform one of the most important functions in the solar system, but they don't really do anything. They don't really do anything special. I mean, let's talk about each of these systems. Panels produce electricity for us. Controllers kind of help us regulate that. Wires transfer the electricity. Batteries store the power. But what inverters do is to convert the DC that is inside the battery to AC that we can use. As you know, energy we use at home is in alternating current. NEPA electricity is in alternating current. This is kind of like how it looks like, whereas this is just a line. So an inverter is a electrical device that converts power. Let's say that converts DC to AC, converts direct current to alternate current. Yes, let me say this. Batteries store DC. Batteries cannot store AC. You can't really store AC. By definition, you can't store AC in a device. And the only way you can really store AC is by one of those what they call them now, rotating battery system. But that's not relevant to our study. So the job of an inverter is to take the DC that is inside your battery. It takes that DC that is inside your battery and it converts it to AC, alternating current. Now, as you know, DC means direct current. And DC is something like this, just a straight line. Maybe something like this, probably at 12 volts. This is 0. So just something like this. But AC, it's not a straight line. Now, there are two types of inverter, at least as relevant to our field of study. We have the pure sine wave. As you know, AC is sine wave. So an inverter converts the DC to AC. A pure sine wave inverter would usually convert that DC to something like this. It converts it to a pure sine wave. This is a pure sine wave. And as you know, a pure sine wave is kind of uniform this way. And the second type of inverter we have is the modified sine wave. Some people in our line of field actually call modified sine wave sachet inverter. That's what some people call it, sachet inverter. But modified sine wave has cheap electronics, cheap components in it, so it doesn't really have complex electronics like all those advanced MOSFETs and inductors and so on and so forth. So instead of achieving a pure sine wave, it cannot achieve a pure sine wave. What it can do is to approximate pure sine wave by producing a square wave. This is the wave pattern produced by a modified sine wave. Now you see these edges, they're a problem. For those of you in electrical engineering, and probably, I don't think I used to do this, electrical engineering, the course, what's his name? Dr. Adu will be teaching EEE 2 something or 3 or something on is it machines? No, I don't think it's machines. I'm going to be treating you something, and part of what we'll be treating you is why this modified wave is bad for some components. Now, like I said, two types of inverter: a pure sine wave that produces this pure wave here, and the modified sine wave that produces this. Pure sine wave is just like NEPA. The electricity produced by NEPA is pure sine wave. But this modified sine wave, which is like a cheaper form of inverter, has some issues with it. One of those issues is these edges. Edges cause I don't know the exact term we call it in machines, but they have any device that has an a kind of a coil in them. Any device that has a coil in them usually have issue with this modified sine wave, because that coil, okay, I will call it angular something. I don't really remember the term. So I hope someone can help me with that. Any device that has coil in them and you run them with a modified sine wave, they will make this humming background sound. You know the way a clipper that the barbers use to cut your hair, the way it sounds, that's the way things such as fan. Well, not all fan. There are some smarter fans that they are making nowadays that are suitable for solar. I think they call them DC fan. Anything that has an AC coil, let me emphasize that. Anything that has an AC coil in it will make this humming background sound. And this humming background sound can do two things, or three things. First, it's waste power. That sound is a form of wastage. Two, it can spoil the component, the device, because that sound is going to build up heat, and that's excessive heat being subjected to that heat continuously can spoil the device. Now this device can be a fan, those old fans. It can be a fridge. It can be a it can be a blender. It can be ceiling fan. It can be anything that has coil in them. Anything that has an AC coil in. If it's a DC coil, there's no problem. But AC coil is a problem. The third issue with it is the noise. Customers find them very annoying. Very, very annoying. That's why when people go for a smaller package, like the one I and what's his name, Mujib, went to install at Northgate, we tell them the issues or the complications that come with such an inverter. Now, of course, the question is, how do you choose between a pure sine wave and a modified sine wave inverter? Well, it depends. First of all, we have talked about how to determine the rating of an inverter. We have talked about that. The second thing we need to talk about is, how do you choose if you are to use a pure sine wave or modified sine wave? Almost every time you work, always go for the pure sine wave one. It's much better than. But the thing is, pure sine wave are expensive. For example, okay, you should know this: modified sine wave are rated in watts, while pure sine wave are rated in VA. Still the same thing: voltage and then current is still power, and watt is still power. But watt, as you know, is real power, and VA is a reactive power now. And this is probably going to be 1 kilowatt, and this is 1 kVA. Now a 1 kilowatt pure modified sine wave inverter, this is modified by the way, and this is pure. A 1 kilowatt modified sine wave inverter will cost around 40k, while the pure sine wave one will cost around 130k. You can see the huge price difference between them. So it depends on the package you are installing actually, and that's what will determine which inverter you are using, and also if the customer can afford it, right? For example, if a customer is someone that is going for a 100 Ah battery, you'll probably want to go for this, because someone going for an 100 Ah battery might not be able to afford this, because this inverter is almost the price of a 100 Ah battery on its own. So far we have talked about what inverters do. They convert DC to AC. We have talked about the types of inverter, which is the pure sine wave and the modified sine wave. We have talked about rating of inverter. We talked about the disadvantage of modified sine wave and why they are an issue. And we have also talked about how you choose an inverter. Please indicate in the comment section that you are following me. Good. Thank you very much, Adeoluwa and David Jimo. Yes. So I don't need to tell you about the internal workings of an inverter, the components in it, and so on and so forth. It's kind of straightforward, but it's also not relevant to what we're doing. And let's just talk a little bit more on pure sine wave inverters and how they work and everything. You see, pure sine wave inverters are they usually start from 1 kVA. There is 1.5. Assignment number 1: list all the ratings of pure sine wave and modified sine wave inverter. And when you list, as you list them, know them. If you list one, so like 1 kVA, search online, check products, check pictures, familiarize yourself with their pictures on the product. That's assignment number 1. We have 2 kVA, we have 2.5 kVA, which is what we use in our last meet, and so on and so forth. But pure sine wave actually come with extra features. Let's talk about the extra features that they come with that make them so great. First, chargers. Almost all pure sine wave inverter that I've seen so far excuse me please almost all pure sine wave inverters that I've seen so far come with a NEPA charger. That's what we call them, an AC charger, such that apart from charging with the solar panel, whenever there's light, instead of the panel to be taking power from the battery, it starts giving power to the battery and to convert the AC back to DC, which is the job of a converter, by the way. And it converts the AC back to DC and start charging the battery. Of course, those are not what we call hybrid inverter. People mix them up and say because the inverter has charger, we call it hybrid. No, that's not why we call it hybrid. We'll get into what hybrid inverters are very soon. So apart from having chargers, they have what we call the UPS mode. I love this mode. This is uninterrupted power supply, such that whenever there is light and the light is sufficient enough, the inverter will silently, or most of the time it doesn't silently, just beeps. It will switch away from taking power from the panel and from the battery and start giving power through NEPA. So let's put it this way. This is NEPA and this is solar. Or let's call it battery. This is the inverter and they are both plugged. The inverter is supposed to give power to the house. Now, when there is light and the light is sufficient enough, the inverter will stop taking power from the battery, start taking power from the light, supplying the light directly to the house, and take part of that power to be charging the battery. I hope you were able to understand my analogy that way. So what else is great about pure sine wave inverter? Another thing I love about them is the protection. They have a lot of protective stuff in them. The older models didn't have it. That's why people hated solar back then. But the newer ones do. For example, they have breakers and such in them. No, mostly breakers. I don't think they have such. So most of them don't have such. They have breakers in them. They have they have overloading protection. They have overloading protection whenever you are inching closer to their limits. And how do you know the limit of an inverter? It is by its rating. If an inverter is 1 kVA, it's probably around 800 watts limit, right? So they also have the battery protection. They protect the battery. Whenever it is low, they cut power to your house, and whenever it is full, well, they know not to be charging it again. They kind of do that quite well. So that's the major things about pure sine wave inverters. But what's the issue with them? Well, when I say issue with pure sine wave inverter, I don't mean that modified sine wave inverter are better than pure sine wave in that issue. They are not actually. This is an issue with both of them. They usually have issue with lightning. How do you spell lightning? And that's thunder, by the way. They have issue with lightning. Whenever there is a lightning strike, um, perhaps not even at the house, perhaps even close to the house. Well, Edwin is asking if inverters don't have surge protections, why do they have surge ratings? Well, I don't really know what you mean by surge ratings. Oh, yeah, I think I know what you mean by surge ratings. Yeah, some inverters will be 1 kVA. They will tell you the power is 800 watts and they probably have surge up to 1500 watts. This surge isn't like a surge protection. What it means is that you see electromagnetic devices such as motors, for those of you in electrical or in SESE, they have what we call starting current. They have what we call starting current. You see, those starting currents are usually higher than the rating of the motor themselves. If a motor is rated 500 watts, when it starts, like in the few seconds that it starts, such as an AC or a fan or a fridge, all those things, when they initially start, they usually go up to around 1000 watts. In a few seconds, by the way, this is not supposed to last up to a minute before they settle back. So inverters anticipate that. So that's why they leave this surge rating, like a spacing, like an allowance for you for devices such as fridge and so on and so forth, so that when they start, they don't spoil the inverter. But you're not supposed to operate in this region for too long. At most 10 seconds. Operate around that region and leave and go back to the normal rating. I hope that clears this up, Edwin. So I was talking about lightning. Even if it's just a little bit, you see, static electricity, high voltage, and so on and so forth are going to get into the inverter. And when they do that, they're going to spoil a lot along the way. And this is why. Well, inverters have fuse. I'm sure you know what a fuse is. They have fuse. They have breakers. They have breakers. They have all sorts of protective things. But you see, most of the protective stuff that we have can't defend against lightning. Lightning, I think, can reach about 30,000 volts or so. Very high voltage. Lightning is very high voltage. Before this fuse even have time, by the way, fuse will probably not do anything in case of lightning, because lightning works on high voltage, low current, not high current. And fuses are only meant to protect against current. That's why they have current rating on them, such as 10 amps, 20 amps, 30 amps, and so on and so forth. So they are not meant to protect against high voltage. So if lightning passes through, nothing will happen. It will not even cut. But for the breaker response time is so low that the lightning will have already done all the damage it wants to do before the breaker reacts to it, before breaking it off. But there is one device that helps in such a situation, and then Mr. Hosseini or Edwin, someone mentioned it in the last class, and that is the TVS, a transient voltage suppressor. It is a diode. Edwin, thank you. It's a diode that its main job is to kind of cut it off when it detects high voltage. It acts like a form of shunt and cut off it kind of shunts the high voltage, and it does that really well. The only issue is I don't understand why inverters don't add it. Most inverters don't add it. Maybe they just want your inverter to spoil so that you buy another one. I think that's the case. So that's one issue with inverters, the lightning. But some people try to solve this. I'm giving you tips, right? This is not really part of the lecture, but I'm giving you a tip. Some people try to solve this through earthing. Like I told you, the voltage flows from a region of high potential to low potential, and there's nothing as low as the earth. So whenever there is lightning or a surge or anything, earth can help. They have this wire that you can plug an earth wire to their body, those inverters, and ordinarily you would think this is a good thing. It is a good thing. It works. It helps. But I had a rumor sometimes last 2 months from one of my friends, that one of my colleagues that we work. I think we even have a job to do tomorrow. One of my colleagues that we work, he told me that there was an installation he did that lightning actually passed through the earth to the inverter. Can you imagine? Like, just pass through the earth to the inverter to destroy the inverter. I was kind of laughing all through, like, what then is the point of earth? But by the way, you should always earth. That kind of thing will only happen if the earth was bad. People think earthing is just digging the floor and putting a rod inside. No, you have to control the salinity level, you have to control the pH level of the soil, you have to control how deep you go, you have to control the amount of charcoal you add. There is a lot that goes into it. That's why I don't do it. Whenever the customer wants to do it, I contract it after. Let me mention this. Try to specialize, okay? Don't do everything. Don't be jack of all trades. Mujib saw it in the last job we did. A mistake we made when working cost us about 30K, close to that. So mistakes cost you a lot of problem, right? It costs you a lot of problem. So try not to be jack of all trade, by the way. So try to specialize. Things that are not your specialty, don't do it. Yes, that's a good question, Mr. Fatai. So earthing is one of the ways you can protect. But earthing is for when the lightning has already reached the inverter, and it doesn't always work because most people don't know how to make earth. So it will almost always certainly spoil your inverter. But there is another solution, and that solution is preventing the lightning from striking in the first place. If you can prevent the lightning from striking in the first place, you don't have much issue. And the way you prevent that is what we call the lightning rod, or as most people call it, thunder arrestor. A thunder arrestor is like a kind of like a fishing rod for charges. If this is a house, they will usually install it on top of the roof. It usually have 3 spikes, or about 4 spikes, and it will run through all the way to the earth. Now, a thunder arrestor, most people think a thunder arrestor's job is to catch lightning. No, thunder arrestors don't catch lightning, right? They do, but that's not really what they're designed for, right? If a thunder arrestor is always catching lightning, that's a huge problem for solar systems. Because if you install solar here and thunder arrestor is always attracting lightning every time, eventually the solar panels are going to get spoiled. A thunder arrestor's primary job, is to take up charges away from a cloud. Let's say this is a cloud moving overhead. Clouds have positive, negative inside them. And when this positive and negative kind of collide, that's what produces lightning. The job of the lightning arrestor, or thunder arrestor, or lightning rod, as we call it professionally, its job is to takes one of the charges. I don't really remember which one, either positive. Someone can remind me in the comments. I know it takes either positive or negative. It's kind of like extracts it from the cloud. And by extracting it, it actively extracts it. And by okay, I think Earth should be about negative. So if Earth is negative, then it should be positive that it is taking. So it kind of removes the positive charge from the cloud. And as you know, Earth is negative, it will repel the negative charge. So by doing that, and thank you very much, Kebi, it attracts the positive charge and repels the negative. By doing that, the cloud will most like, or the clouds overhead will just be negative, and without the positive charge, there won't be lightning. So the main job of a lightning arrestor is actually to prevent lightning from striking in the first place. But if lightning eventually strikes for any reason, a lightning arrestor is also designed to kind of like attract that lightning to itself and carry it down. Now, if you are carrying something of 30,000 volts or so, you need thick wires. That's where most people make mistakes. You see, the wires you use to connect the lightning arrestor needs to be quality, grade. Most people buy fake one, but this is not a course on lightning arrestor, so I won't get into that much. And they use copper for that. Everything has to be copper. Even the nails have to be copper. So, yes, That's good. We have talked about the issue with inverters. Now, one of the things that make inverters spoil, the primary things that make them spoil is this lightning. So let's talk about our good friend, the hybrid inverter. The hybrid inverter. So, what is an hybrid inverter? Oh yeah, assignment number 2. I've given you one already. Assignment number 2, I want to know the efficiency of a pure sine wave inverter and the efficiency of a modified sine wave inverter. So, hybrid inverter. The main reason why we call hybrid inverters hybrid inverter is because they have charge controller inbuilt in them. Normally you would have to have a panel, a controller, a battery, and an inverter. But hybrid inverter take away the controller, so that you will just connect, instead of connecting the panel to the controller, you connect the panel to the inverter. You connect the battery to the inverter. So hybrid inverters kind of like serve as a central processing unit for the entire system. The hybrid inverter will usually have a place for panel, a place for battery, a place for AC inputs. You can see it has up to like 3 inputs, and of course the AC output. But what makes them really great? Well, first of all, unlike regular controllers that you can just throw in any kind of panel voltage into them, hybrid inverters are really specific in what they take in. As much as it depends on the kind of inverter, there are 1.5 kVA hybrid inverters and so on and so forth. And most of the hybrid inverter usually come with MPPT controller. Not all of them, but most of them come with MPPT controller inbuilt in them. There is one advice I got from a colleague recently. He said, Daniel, if you're using an hybrid inverter, make sure the inverter is at least 3 kVA or 2.5 kVA at least. All these 1.5 kVA hybrid inverter, he claimed that they are not good. I've used them before, they work fine. But even me, I feel like they are using PWM inside and lying to us that it's MPPT controller. Either way, it works so far. But normally, hybrid inverters are supposed to use MPPT controllers in them. And the reason for that is simple. You see, when I say an inverter is hybrid, the panel voltage it expects needs to be high. Sorry, excuse me. It's expecting high voltage from the panel. And if you're expecting high voltage from the panel, you definitely have to be using MPPT controller. You can't afford to use PWM controller. So, while it depends on the inverter, some hybrid inverters, such as Felicity IVEM inverters, Felicity have 2 types of inverters in their brand. They are all pure sine wave, by the way, but they have the IVEM and the IVPS. The IVEM are kind of like the really smart hybrid inverters and transformerless inverters. Yes, under pure sine wave inverters, we have inverters that don't use transformer, they just use inductors and so on and so forth. And we have the IVPS. Sorry, this is PS. We have the IVPS inverter. The IVPS use transformer, by the way. But I usually prefer to use the IVEM because they're hybrid and they're smarter. But IVEM starts from 3 kV. So Felicity IVEM inverters usually have a panel input voltage that ranges from 150 volts to 500 volts. If your panel voltage is less than 150 volts, it won't charge the battery. If it's more than 500 volts, you will damage the inverter. So you need to keep it between this. Most of the time, people target 250 volts, but it can go all the way to 400. There's no problem with that. The reason why its input voltage is so high is because of the way hybrid inverters work. You see, hybrid inverters are smart. When there is a lot of sun and the battery is kind of charged, and you want to be using power in your house, instead of converting DC from the battery to the house, what you would do is to convert the DC from the panel directly to the house. So it's like converting 250 volts DC to 250 volts AC. So that way it won't use the battery at all. Hybrid inverters are the only inverters that don't use the battery at all some of the times. The pure sine wave inverters, no matter how you configure them, even when there's a lot of sun, they will still be using the battery. Remember I told you the three functions of a battery: to provide backup and to support the panel. But for an hybrid inverter, it doesn't need to support the panel because the panels are already at very high voltage. Oh yeah. Okay. So whenever there is light, it also knows to either use panel or use light. You see, normal regular inverters, when there is light, they charge the battery with the NEPA light, and solar panel is still also charging the battery. So you have two things charging the battery. We talked about this in the last Google Meet, why people used to say charging your battery with light is going to spoil it. And that's, people say that because of this issue. But hybrid inverters know to choose one of the two. They don't use the two at once to prevent issues. That's another difference. I've told you like 3 things or 4 things that make hybrid inverters special. That's probably going to come out in the test. Alright, so we have talked about hybrid inverters. Now let's talk about what someone was asking about recently, and that is connection of inverters in series and parallel. To get more power from an inverter, you can connect them in series or in parallel. It kind of depends on what you are targeting anyway. But the question is, when do you connect them in series, and when do you connect them in parallel? When you connect two inverters in parallel, you will be getting same voltage, as you know, and increased current. But if you were to connect them in series, you will get same current, increased voltage. But this connection is not as simple as we did in batteries and in panels. You can't just take two inverters and hook them up together. The moment you try, it's probably going to throw you away. Don't try it, except with inverters that are designed for that. This is probably like Felicity inverters. Those are the kind of inverters that are designed for ITEL and smart inverters. They usually come with a kind of a communication cable that you can connect that communication cable with the two inverters. Let me tell you why it is a problem. Let's assume one inverter is producing this sine wave. Let's assume another inverter is producing, let's assume another inverter is producing this sine wave. And let's assume a third inverter is producing this sine wave. What's the difference between these 3 waves? Who can tell me the difference between these 3 waves in the comments? There's a word I'm looking for. Those of you that did DSP should know what that word. Those of you that did Taylor series and so on and so forth, you should know what that word is. Alright, to save time, and I feel like there's going to be a lag in the video because of this, the word I'm looking for is phase. They all have different phases, right? They begin at different time. Your phase is different. So you can't just go on and plug in them together. They have to have, their phase have to align Oh yeah, sine wave. No, that's not what I was looking for. Their phase have to align for you to like connect them together. So assignment number, is it 3 now or 4? I want you to read on and explain in full detail how connecting inverters in series and parallel work. Tell me the role phase plays in it. Tell me a scenario, an example of how you would connect inverters in series and parallel. Assignment number 4, I want you to explain how you decide between connecting inverters in series or connecting them in parallel. Assignment number 5, I want you to read on three-phase inverters. We're going to explain three-phase inverters. So let me repeat the last 3 assignments again. Assignment number 3 is for you to explain how you would connect inverters in series or in parallel. Using explain that and tell me the role phase plays in them. Assignment number 4 is for you to tell me what determines if you will connect an inverter in series or in parallel. Assignment number 5 is for you to explain three-phase inverters. So, thank you very much, everybody. I feel like we have come to the end of today's lecture. If you have any question, any comments, send it to the chat. I will send the attendance right now. So I've sent the attendance to the live chat. Please take your time to read through it. Let me send it with the main account so you don't have any issues with it. So you don't have any issues with it. So this is the last chance for you to ask any question you may have. The next time we'll treat this again is in our live meeting. Imole, please schedule a live meeting, a Google Meet for us. And then once again, please, the deadline for the assignment given for the team assignment is Tuesday. I will send a link for you to submit your videos. Oh yeah, that reminds me. They said you are to send your videos online actually and tag us. That's what they said. So I will send more information about that to the group anyway. And yes. So any question, please. If you have any question, now is the time for you to ask. The meeting ends in about a minute or so.